Okay, this video covers more binomial distribution scenarios, so it's just more practice of what we've been already learning. Please remember, binomial is a yes-no situation, and we have a fixed number of trials. The fact that you have a fixed number of trials pretty much lets you know that you're probably working with a binomial. They give you the formula on the formula chart, which is n choose x, p to the x. I like to use q for failure. Basically 1 minus p to the n minus x. All right, remember the n choose x is basically a combination that looks like this. They give you the expected value, and they also give you the standard deviation. N, of course, is the sample size. P is the probability of success, and 1 minus p is failure. I like to use q for failure, but that's the way they give it. Okay. All right. So in this next scenario, we have a multiple choice test. We have a true false test, and Johnson is guessing on it. So the probability of guessing anything correct is 0.5. So basically it's either wrong or it's right. So yes, this is a yes-no situation. We have 20 questions. So our trials in this case is 20. The fact that we have a specific number or trials lets me know this is probably going to be a binomial. And we satisfy everything else, which is independence, because we're guessing, so it doesn't matter what it is. Our probability is fixed. So consequently, this right now is a binomial. It's different than the geometric. The geometric is how many questions would they have to guess to get the first right one. In this particular case, we know that we're just guessing 20 times, okay? So the first thing it says, what is the probability that he gets no more than 14 correct? Well, no more than 14 means it could be 0, 1, 2, 3, all the way up to 20, but we want no more than 14. Well, when I look at this, I'm circling more than one number. If I'm circling more than one number, this lets me know that it's a binomial CDF. Well, remember, a CDF is just the sum of the PDFs. So essentially, I'm doing the probability of 0 plus the probability of 1 plus the probability of 2, all the way to the probability of 14. And so when I'm showing my work, I'm going to show it as a sum of the PDFs. So 20 choose 0. The probability of guessing correct is 0.5 to the 0, and then guessing wrong is 0.5 to the 20th. And then it says, this is 20 choose 1. I don't have to show this one. 0.5 to the first, and then 0.5 to the 19th. Please note, this plus this has to add up to the number of trials. But I do have to show my first and my last. My last one would be 20 choose 14. So I'm 0.5 to the 14th. 20 minus 14 is 6. All right. So here's the way I do this on the calculator. So on the calculator, that was my work shown. I need to show my lowest. First off, let me back up. I need to show my lowest, and I need to show my highest, and then plus dot dot plus. But on the calculator, I'm just going to go second vars, binomial, CDF. My trials are 20. Our probability of guessing correct, or Johnson's probability of guessing correct, is 0.5. And we need at most, or no more than 14. And now I just added them all up. So the probability that he gets 14 or less questions right is about 98%. So there's about a 98% chance that he makes below a 70, which means there's about a 2% chance that he makes greater than a 70. The next thing says, what's the probability he gets exactly 14 questions correct? So if I make my number line 0, 1, 2, 3, dot, 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 13, 14, 15, dot, 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 all the way to 20, I'm only circling one number. I'm only circling 14. If I'm circling a singular number, I'm looking for an exact number, this is a PDF. All right. So a singular value is a PDF. So 20 choose 14, 0.5 to the 14th power, then 0.5 to the 6th. This is my probability of correct, probability of wrong. 14 and 6 add up to 20. That looks pretty good. And so then I go second vars, binomial, PDF, trials are 20, probability of guessing correct is 0.5, and I wanted to guess exactly 14. So this is a probability of getting a 70%. So 0.0369. So basically, there's about a 4% or 3.7% chance that he gets a 14 out of 20, and 14 out of 20 would represent a 7. What's the probability that he gets less than 10? Be careful. So that means less than 10. So I need to circle these numbers. And by the way, you do not have to make a number line, but I find that students that do tend to do score better. So you may want to do that. You don't get partial credit for doing it, but I need the PDF of 0 all the way to the PDF of 9. So it's the PDF probability of 0 plus the probability of 1 plus the probability of 2 all the way to the probability of 9. So it's the sum of the individual PDFs. So 20 choose 0, 0.5 to 0, this should say 0.5 to the 20th, 20 choose 1, 0.5 to the first, 0.5 to the 19th, and so on and so forth until I get to 20 choose 9, which is 0.5 to the 9th and 0.5 to the 11th. Now, what I had to show is I had to show the lowest and the highest. You don't need to show anything extra. I did this just for the notes. And by the way, if you show extra and it happens to be wrong, they count off for it. So generally speaking, probably don't want to show extra, just probably want to show the lowest and the highest. So I'm circled multiple values. Multiple values tells me I'm working with a CDF. And if 0 is included, I don't have to subtract. So this is going to be second bars, binomial, CDF, trials is 20. The probability of guessing correct is 0.5. And my X value, I want less than 10. Well, the number less than 10 is 9. And so there's a 0.4119 chance that I get that Johnson guesses 9 or less correct. In other words, the probability he gets less than a 50 is about 41%. The next question, what does the standard deviation mean for the expected number of correct answers? As I said earlier, those are on the formula chart, and the mean is the number of trials times the probability. Our trials is 20, our probability is 0.5. So in this case, 20 times 0.5 equals 10. On average, we'd expect to get 10 answers correct. Or on average, Johnson would get 10, or in the long run. Please make sure that you're including the sentences. That's very important from this point forward. Prior to this point, we were not stressing it, but at this point, it's required. All right, I prefer to do NPQ. However, the formula chart does it this way. N times the sample size, or the number of trials, times the probability of success, times 1 minus the probability. I like to use Q. But remember, if you do use Q, you have to tell people that it's 1 minus P. Okay? So here's what I need to show. 20 times 0.5 times 1 minus 0.5, or you could just show it like this. This is all that you would have to do. All right, that would be work shown. Then I need to calculate it. All right, so here we go. 20 times 0.5 times 0.5. I like doing square roots this way. I like using this button right here because after I've done the work, caret 0.5. So raising it to the half power, I find that I make fewer errors when I do it this way. So I like to go ahead and do the calculation and then use the button right here and raise it to the half power, which is taking the square root of it. And I find that I have 2.236 correct answers. So this would be my expected standard deviation. So here's my mean, or my expected number of correct answers, and this is my standard deviation. All right, the next. What's the probability that Johnson gets at least 14? When I see the word at least, we learned previously in probability, that means we're going to be working with a 1 minus. Again, I can get 0 correct, or Johnson can get 0 correct, 1 correct, 2 correct, 14 correct, 15, all the way 20. We want at least 14. I circled multiple values, so this means I'm working for a binomial CDF. So let's talk about the work I have to show first. The work I have to show would be the PDF of 14 plus the PDF of 15, all the way to the PDF of 20. Of course, we know we can just do the lowest and the highest. So 20 choose 14. The probability of getting it correct is 0.5 to the 14. 20 minus 14 is 6, so this is 0.5 to the 6th power. Plus dot 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 plus 20, choose 20, 0.5 to the 20th. 20 minus 20 is 0. All right. So how do I do this in calculator? This is where you have to be really careful. So first off, we know it's going to be a CDF because we have more than one value. And we always subtract out the highest value we don't want. I want 14, so I'm not subtracting it out. I'm subtracting out 13. So here we go. 1 minus, second vars, binomial, CDF, trials are 20, probabilities of guessing correct is 0.5, and the highest value I didn't want was 13. I wanted 14, so 13. So 0.057. So the probability to make a 70 or better on this test is 0.0576. So if they have to guess, it's a pretty small possibility that we could pass, but it's about 6% or 5.7%. All right, if you're guessing on a true-false test. What's the probability that they get at least 10? Once again, we have at least. So once, as we said before, it's going to be a 1 minus situation. We need at least 10, which means we need 10, 11, all the way to 20. So in this case, 10 out of 20 is a 50. So this is the probability of getting a 50 or better on the test. So we need the PDF of 10 plus the PDF of 11 plus the PDF all the way up to the PDF of 20. We only have to show our lowest and our highest. So 20 choose 10, 0.5 to the 10th, 20 minus 10 is 10. And then the last one, the highest one, 20 choose 20, 0.5 to the 20th, 20 minus 20 is 0. So 1 minus binom CDF, and the lowest value I wanted was 10, so we always subtract out the highest that I don't want. The highest that I don't want is 9. So 1 minus the binomial CDF of 9. So 1 minus second vars, binomial, CDF, trials is 20, the probability is 0.5. The highest value that I didn't want was 9. I wanted 10, so I don't subtract it out. I subtract out the highest that I don't want, which is 9. And I find out that it's 0.5880 right here. Okay. What's the probability that he gets more than 10? Be careful. So we're looking for the probability that X is greater than 10. That means we need 11 through 20. So once again, it's a CDF. We have multiple values, so this is going to be a CDF. All right. So PDF of 11 all the way to the PDF of 20. So here's 20 choose 11. Probability of guessing. This is correct to the 11th. 20 minus 11 is 9. And then there's 20 choose 20. So there's my lowest and there's my highest. Now I have to be really careful here. All right. So with that said, 0 is not included. If 0 is not included, I'm going to have to do a 1 minus. Anytime 0 is not included, I have to do a 1 minus. So 1 minus the binom CDF. And remember, we're always subtracting out the highest value we didn't want. We want 11. We're not interested in 10. So we subtract out what we don't want. So 1 minus the binomial CDF of 10. So 1 minus second vars, binomial CDF, trials is 20, probability is 0.5, and my X value is 10. And I end up getting 0.4119. That's the probability of getting more than 10. That's probability of getting greater than a 50 on this test. All right, what's the probability that Johnson gets 9 to 13 questions correct? In other words, 9 satisfies, 10 satisfies, all of these satisfy. All right, so I have to do, this is going to be a binomial CDF because we have more than one value circled, and we'll come back to what that is. But right now, it's for work shown, it's the PDF of 9 plus the PDF of 10, all the way to the PDF of 13. So 20 choose 9, 0.5 to the 9th, etc. 20 choose 13, etc. How do I go about doing this? I always start with the highest value I want, which happens to be 13. So I'm going to do the binomial CDF of 13. That's the highest value I want. And then I'm going to subtract out the highest value I don't want. So minus the binomial CDF, and the highest value I don't want. I want 9, so the highest I don't want is 8. All right? Never take away what you want because you want it. Take away what you don't want. So, second vars, binomial, CDF, X value happens to be 13, minus second vars, binomial, CDF, X value, highest value I didn't want. I wanted 9, so I'm taking away 8. That's the highest one I don't want. And I end up getting 0.6906. All right. Next, what's the probability they get between 9 and 13? This doesn't say from 9 to 13. Notice the difference. This is between. So in other words, we want 10, 11, and 12. So that's the PDF of 10 plus the PDF 11 plus the PDF of 12, but I only have to show lowest and the highest. So 20 choose 10 and 20 choose 12 plus dot, dot, dot in the middle. Once again, this is just like above. We're going to have the binomial CDF of the highest thing we want. We wanted 12. And then we're going to subtract out the highest thing we don't want. So binomial CDF. We want 9, so the highest thing we want 10, so the highest thing we don't want is 9. So this is the binomial CDF of 12 minus the binomial CDF of 9. So second vars, let me clear that out. Second vars, binomial CDF, the highest thing we wanted was 12, minus the highest thing we didn't want. Trials is still 20. We wanted 10. The highest thing we didn't want is 9. And we end up getting 0.4565. All right. So make sure that you're very careful with this. I highly recommend using a number line to identify what it is that you need. You only have to show your lowest and the highest. And remember that a CDF is basically the sum of the individual PDFs. At least is the 1 minus situation. And if you have multiple values, you have to use a CDF. All right, I hope this video was helpful. Thank you.